On January 9, 1992, astronomers Alexander Wolszczan and Dale Frail published a discovery that should have been impossible. They had found the first confirmed planets ever detected outside our solar system. 2 worlds, roughly 3 and 4 times the mass of Earth. But these were not gentle worlds circling a friendly yellow star like our own sun. They were orbiting the collapsed corpse of an exploded star, a millisecond pulsar called PSR B1257+12, spinning more than 160 times every second and blasting its planets with lethal beams of radiation on every single rotation. The star itself had likely destroyed any original planets in a supernova long before these worlds ever existed, meaning the planets astronomers were now studying had almost certainly formed a second time out of the wreckage of the star's own violent death. Wolszczan had originally been searching for something entirely different. Subtle timing irregularities in the pulsar's otherwise metronomic radio pulses, which fired with such precision that the pulsar should have ticked like a cosmic clock every 6.2 milliseconds without fail. Instead, he noticed the pulses arriving very slightly early or late in a regular repeating pattern, the unmistakable gravitational fingerprint of unseen worlds tugging the pulsar back and forth as they orbited it. A follow-up study in 1994 confirmed a third planet in the system, a body barely twice the mass of our own moon, making it, to this day, one of the least massive exoplanets ever detected by any method. It was, and remains, one of the strangest opening chapters imaginable for an entire field of science. The very first alien worlds humanity ever confirmed were not paradises. They were radiation-blasted graveyards, spinning around the ashes of a star that had already died once. In the more than 3 decades since that discovery, astronomers have confirmed thousands more exoplanets, and it turns out that hostile, nightmarish worlds like these are not the exception in our galaxy. They may actually be closer to the rule. From planets raining molten glass sideways at 7 times the speed of sound, to worlds being slowly swallowed alive by their own stars, the true diversity of exoplanets makes almost anything you could imagine from science fiction look tame by comparison, and it turns out that reality has consistently outpaced even the wildest speculation of the writers who came before the data existed. But scattered among all of that horror, astronomers have also found a small, precious handful of worlds that might genuinely be more comfortable to live on than Earth itself. This is a tour through both extremes, the worst exoplanets ever discovered, and the best ones that might be waiting for us. Let's start with the darkness. TRES-2b, discovered in 2011 by astronomers using data from NASA's Kepler Space Telescope, is a gas giant roughly 1.5 times the mass of Jupiter, and it holds a record that sounds almost too strange to be real. It is the darkest planet ever discovered, reflecting less light than fresh charcoal or black acrylic paint, with an albedo measured at less than 1%, far darker than any planet or moon found anywhere in our own solar system. Less than 1% of the light hitting its atmosphere ever bounces back into space. Astronomers still are not entirely sure why, though the leading theory involves exotic light-absorbing chemicals in its clouds, possibly vaporized sodium and potassium, or compounds like gaseous titanium oxide, cooked into the atmosphere by the planet's extreme heat, which sits at a blistering 3,000 degrees Fahrenheit, thanks to an orbit that carries it around its star once every 2.5 days. Despite swallowing almost all the light that reaches it, TARES-2b still glows a faint, dull red from its own internal heat, like a smoldering coal that never quite goes out, orbiting so close to its star that its surface temperature rivals fresh lava. Then there is 55 Cancri e, part of a 5-planet system where 4 of the worlds are unremarkable gas giants, but the innermost one is genuinely horrifying. It orbits its star so closely that one entire hemisphere is a permanent roiling ocean of molten lava, while the other hemisphere, tidally locked and forever facing away from the star, sits in total, eternal darkness. Between the blazing day side and the frozen night side lies a strip astronomers have nicknamed the Twilight Zone, a thin band of permanent dusk where the two extremes bleed into one another. Some early research even suggested that if the planet's interior carbon content is as high as models predicted, enormous amounts of its interior could theoretically be crystallized into diamond, though more recent analysis has cast serious doubt on the so-called diamond planet interpretation. And most researchers now suspect it is a more conventional, if still hellish, world of lava and exposed rock. HD 189733b is even stranger, and unlike some of these worlds, we actually know its true color because astronomers using the Hubble Space Telescope managed to directly measure it in 2013. From a distance, this gas giant looks like a serene, deep cobalt blue, almost identical to Earth as seen from space. Up close, that blue comes from silicate particles suspended high in its atmosphere, hard glassy grains that scatter blue light the same way our own sky does. In 2015, astronomers at the University of Warwick produced the first ever weather map of a planet outside our solar system, mapping wind velocities on opposite sides of the planet using the Doppler shift of sodium absorption lines, and what they found was terrifying. Winds circling the equator at over 5,400 miles per hour, roughly 7 times the speed of sound. For comparison, the fastest wind gust ever measured on Earth, recorded during a tropical cyclone in 1996, was only 253 miles an hour, more than 20 times slower. On HD 189733b, those hypersonic winds don't just blow, they drive silicate particles sideways through the atmosphere at those same extreme speeds, meaning any hypothetical structure caught in the open would be sandblasted by horizontal glass shards, moving faster than a rifle bullet. Orbiting its star once every 2.2 Earth days at a blistering 341,000 miles per hour, roughly 63 light years from Earth, HD 18973b remains one of the most intensively studied exoplanets ever found, largely because its bright host star and frequent transits make it unusually easy to observe in detail. A 2024 study using the James Webb Space Telescope added one more grim detail, detecting signs of hydrogen sulfide in the planet's atmosphere, the same compound responsible for the smell of rotten eggs, meaning this scorching, glass-shredded hot Jupiter would also somehow manage to stink. Some planets aren't destroyed by wind or heat, but are simply being eaten alive. Kepler 70b, sometimes called the survivor planet, once orbited a normal sun-like star that later swelled into a red giant roughly 18 million years ago. A red giant so enormous it should have completely engulfed and vaporized this Jupiter-sized world. Somehow, the planet survived being swallowed, though the ordeal stripped away its outer atmosphere entirely, leaving behind only its blazing hot rocky core, a remnant now hotter than the surface of our own sun and still slowly evaporating into space. A planet quite literally living on borrowed time after already surviving its own apparent death. Some researchers have since questioned whether Kepler 70b genuinely exists at all, arguing the original detection signal may have been a statistical artifact rather than a real planet, which, if true, would make its origin story even stranger still. A world so improbable that even its own existence remains up for debate. WASP 12b's story is arguably sadder still. This hot Jupiter orbits so close to its host star, and the star's gravity is so overwhelming that the planet has been stretched into a distinctly egg-shaped world, its atmosphere continuously siphoned away into a glowing disk of gas spiraling into the star. Astronomers estimate the entire planet will be completely consumed within roughly 10 million years, meaning WASP 12b is, in the most literal sense, watching its own slow-motion death unfold in real time, unable to do anything but keep orbiting closer and closer to its executioner. Some worlds combine extremes that should not logically coexist. GJ 436b, a Neptune-sized exoplanet, sits so close to its star that its atmosphere bakes at temperatures hot enough to melt most metals, and yet astronomers believe its surface is covered in solid ice. That sounds contradictory until you factor in the planet's crushing gravity, which compresses water into an exotic, high-pressure form of ice that stays solid even at temperatures that would normally boil it away entirely, a phase of matter that essentially does not exist naturally anywhere on Earth. Another planet that manages the same trick of being both scorched and frozen at once is Coro T7b, discovered in February of 2009, and at the time, the first planet ever confirmed to have a genuinely rocky, Earth-like density rather than the puffy gas of a giant. Orbiting its star in barely 20 hours at roughly 1/23rd, the distance between Mercury and our own sun, Coro T7b's permanently sunlit hemisphere reaches surface temperatures as high as 4,700 degrees Fahrenheit, hot enough to keep much of that side molten, while its permanently dark hemisphere, never touched by starlight at all, is cold enough that researchers suspect it may be studded with frozen rock and mountains. Astronomers believe the blistering dayside likely rains vaporized rock that condenses and falls back to the surface as literal pebbles, in what may be one of the only known worlds where the weather forecast genuinely includes molten stone. Just as strange as HD 29458b, nicknamed Osiris, a planet notable for a very different reason. In 2001, it became the first exoplanet ever confirmed to actually have an atmosphere at all, detected through the way it dimmed its star's light in a specific wavelength of sodium as it passed in front. Osiris orbits roughly 8 times closer to its star than Mercury does to our sun, so close that a full year there lasts just 3.5 Earth days, and its atmosphere is being actively boiled away into space by the star's radiation, streaming off the planet in a long, comet-like tail of escaping hydrogen gas, making Osiris one of the clearest examples astronomers have of a planet slowly, visibly evaporating. One of the most historically important hostile worlds of all is 51 Pegasi b, officially named Dimidium, the very first exoplanet ever confirmed orbiting a normal, sun-like star, discovered in 1995 by astronomers Michel Mayor and Didier Queloz, a find so significant it earned them the Nobel Prize in Physics in 2019. Dimidium is tidally locked, meaning one side permanently faces its star while the other remains in permanent night, and its scorched day side bakes at over 1,800 degrees under winds that can reach 600 miles an hour. Despite being classified as a gas giant, Dimidium carries an unusually large amount of iron for a planet of its type. And as that iron circulates through the atmosphere, it melts, evaporates, and eventually condenses again into clouds, which then rain back down onto the planet, not as water, but as molten iron. And of course, no tour of hostile worlds would be complete without mentioning Venus, often called Earth's evil twin. Despite being almost identical to Earth in size and mass, Venus's thick, crushing atmosphere traps heat so effectively that its surface is hotter than Mercury's, despite Mercury sitting far closer to the Sun. Venus's clouds are not water vapor, but concentrated sulfuric acid, and its surface pressure is roughly 90 times that of Earth's, equivalent to standing nearly a kilometer underwater on our own planet, all while volcanic activity continues to reshape its surface. It stands as a permanent reminder that a planet can look almost exactly like Earth from a distance, and still be one of the most hostile places in the entire solar system up close. Space isn't just full of planets bound to stars either. OTS-44 is something rarer, and in its own way, more unsettling. A rogue planet roughly 11 times the mass of Jupiter, drifting through interstellar space entirely untethered to any star at all. Objects like this are thought to form the same way stars do, condensing out of collapsing clouds of gas, but without ever gathering quite enough mass to ignite nuclear fusion at their core. Astronomers estimate there could be billions of similar starless wanderers scattered throughout our galaxy alone. And some studies using gravitational microlensing surveys have suggested rogue, Jupiter-mass objects could actually outnumber ordinary main sequence stars in the Milky Way, worlds with no sun to warm them, drifting through permanent darkness on trajectories nobody is tracking. Nothing about them is confirmed to be dangerous to us directly, since the odds of one passing anywhere near our own solar system are astronomically low, but their sheer numbers are a humbling reminder of how much of the galaxy remains completely unmapped. Dark objects massive enough to obliterate a planet on impact, floating silently between the stars we can actually see. Some of the strangest worlds of all remain purely theoretical, at least for now. Astronomers suspect that in regions of the galaxy rich in carbon relative to oxygen, particularly closer to the crowded, chemically enriched center of the Milky Way, planets could form with fundamentally different chemistry than anything in our own solar system, so-called carbon planets. On worlds like this, any oxygen that did appear would react instantly with all that carbon to form toxic carbon dioxide smog. And instead of water oceans, models suggest seas of liquid tar, geysers erupting with methane and crude oil, and rainstorms made of raw gasoline and liquid asphalt, capable of igniting on impact with sufficiently hot ground, with diamond or graphite potentially forming naturally in the crust under the right pressure and temperature conditions. No confirmed carbon planet has been definitively identified yet, but the physics behind the idea is sound enough that many astronomers consider it only a matter of time before a strong candidate turns up in the data already being collected. Now imagine something different entirely, not fire, but endless water. Picture standing in the middle of an ocean so vast you cannot see its edges, wrapped in permanent fog so thick you cannot tell if a dim, distant sun overhead means day or night. This is what scientists imagine a true ocean world might actually feel like. And it turns out these are far more common in the galaxy than anyone originally expected. On Earth, all of our oceans combined make up only about 0.025% of our planet's total mass, an almost invisible film of water on a fundamentally rocky world. An ocean planet is something else entirely, a world that could be 40 to 60% water by mass, with oceans so deep they could exceed 60 miles, compared to less than 7 miles at the deepest point of Earth's Mariana Trench, generating pressures at the seafloor of up to 20,000 times what we experience at Earth's surface. We already have hints of this kind of world much closer to home. In fact, several moons in our own solar system, including Jupiter's Europa and Ganymede and Saturn's Enceladus and Titan, are believed to hide vast oceans beneath their icy shells. In some cases, making up as much as 30% of the moon's total mass, kept liquid not by sunlight, but by tidal heating, generated as each moon is gravitationally flexed and squeezed by the enormous planet it orbits. Europa, in particular, has become one of NASA's top priorities in the search for life beyond Earth, and the agency's Europa Clipper mission, launched in October of 2024, is currently en route to study that moon's ice shell and subsurface ocean in unprecedented detail, expected to arrive in the early 2030s. The search for planets like these owes almost everything to NASA's Kepler Space Telescope, launched in 2009 with a single staring mission to watch more than 150,000 stars simultaneously for the tiny, telltale dimming caused by a planet passing in front of them. Before Kepler, astronomers had confirmed only a few hundred exoplanets in total. By the time the mission finally ran out of fuel in 2018, it had confirmed more than 2,600 new worlds on its own. And its data continues to yield fresh discoveries even years after the spacecraft itself went silent, including many of the very ocean world and super habitable candidates astronomers are still studying today. The first confirmed ocean planet was Gliese 1214b, discovered in December of 2009 by the MERTH project, a network of small robotic telescopes specifically built to hunt for planets around dim, unremarkable red dwarf stars. The star itself, Gliese 1214, is about 5 times smaller and 300 times fainter than our Sun. The planet, a super-Earth roughly 2.5 times Earth's diameter and 6.5 times its mass, had a density far too low to be a rocky world, but also far too high to be a gas giant, leaving water and ice as essentially the only explanation that fit the data. Its year lasts just 36 hours, and surface temperatures are estimated to run somewhere between 250 and 535 degrees Fahrenheit, hot enough that the boundary between its steam atmosphere and its liquid ocean below is thought to be almost impossible to define, with any hypothetical ocean permanently hovering right at the edge of boiling. Whatever lies at the bottom of that ocean is likely an exotic form of pressurized ice that refuses to melt even under blistering heat. A layer scientists estimate could be as much as 3,000 miles thick. A more recent candidate, TOI 1452b, discovered in 2022 by researchers at the University of Montreal using data from NASA's TESS Space Telescope, may be an even better fit for a true ocean world. 7 times the volume of Earth, but only 48 times its mass, again suggesting a low-density world largely made of water, this time with a probable rocky seafloor lying beneath it, rather than an endless column of exotic ice. TOI 1452b also orbits a small red dwarf, and not even just one, but 2 stars locked in a wider binary pairing. And unlike the previous planet, this one sits unusually far from its star, rather than close, roughly 2.5 times farther out than Pluto sits from our own Sun, completing a full orbit in just 11 days thanks to how tightly bound the whole compact system is. Water alone does not guarantee life, of course. Complex biology, as we understand it, also seems to need minerals and trace elements, ingredients that pure water worlds may simply lack, unless comets and meteorites happen to deliver them from outside. Or unless a planet like TOI 1452b turns out to have a genuine rocky floor beneath its ocean, where those ingredients could actually exist. It remains an open question, but not an especially discouraging one. So far, astronomers have confirmed more than 5,500 exoplanets across the galaxy, and the search for truly Earth-like, or even better than Earth-like, worlds continues to turn up remarkable candidates. In 2020, a team of researchers led by astrobiologist Dirk Schulze-Makuch published a study identifying 24 exoplanets that might actually be more hospitable to life than Earth itself, worlds the team termed superhabitable, drawn from a survey of more than 4,500 known planetary systems believed to hold rocky worlds inside their star's habitable zone. Their criteria favored planets slightly larger and more massive than Earth, since a bigger planet holds onto its internal heat and its atmosphere for longer. Planets somewhat older than Earth, in the 5 to 8 billion year range, giving evolution more time to work, and planets orbiting orange dwarf stars rather than yellow ones like our Sun, since orange dwarfs burn far more slowly and can remain stable for anywhere from 45 to 70 billion years, dramatically outlasting the roughly 10 billion year total lifespan of a star like ours. Crucially, the researchers were careful to stress that none of the 24 candidates satisfied every single criterion on their list, and that superhabitable does not mean confirmed to host life, only that a planet's conditions, on paper, could theoretically support more biomass and greater biodiversity than Earth currently does. One of the strongest candidates from that list, KOI 5715-01, orbits an orange dwarf nearly 3,000 light-years from Earth in the constellation Cygnus. At an estimated 5.5 billion years old, it is younger than the ideal target age the researchers proposed, but comparable to how much older than Earth's own 4.5 billion years astronomers consider genuinely promising, and it takes about 190 days to complete a single orbit. The planet is almost twice Earth's size, with an average surface temperature only a few degrees cooler than our own, and its slightly stronger gravity may actually help it retain atmospheric heat more effectively. Another strong contender, KOI 3010.01, orbits a star catalogued as KOI 3010 and runs a few degrees warmer than Earth, which researchers consider a genuine advantage rather than a problem, since slightly warmer worlds appear to support broader biodiversity, closer to what the study's authors calculated as the theoretical ideal, a planet roughly 10 degrees hotter than Earth on average. With a radius about 1.5 times Earth's and a probable ocean that could cover up to 60% of its surface, scientists have estimated as high as an 84% chance that some form of life, even if only simple organisms, could exist there. Kepler 186f, often nicknamed Earth's cousin, circles a red dwarf star and holds the distinction, when it was announced in April of 2014, of being the first Earth-sized planet ever discovered inside another star's habitable zone, orbiting close enough to its dim star that its surface should still receive meaningful daylight, likely bathed in an unusual reddish hue given the star's cooler light. Crucially, its axial tilt closely resembles Earth's own, which matters enormously, since a stable tilt produces predictable seasons and a reliable day and night cycle. The same stability Mars notably lacks. A big part of why Mars' ancient oceans are believed to have dried into the barren red desert we see today. Kepler 186f sits about 490 light-years from Earth. Slightly farther out, in the constellation Lyra, roughly 1,200 light-years away, sit Kepler 62s and Kepler 62f, two more strong candidates once considered the very best Earth analogs known before Kepler 186f's discovery, announced together by NASA in April of 2013. Both orbit the same red dwarf star and are believed to be predominantly water worlds themselves, warm, largely ocean-covered planets, where any land that exists is likely limited to scattered island chains rather than continents, environments that could theoretically host anything from simple microbial life to entire marine ecosystems we can barely begin to imagine. With Kepler 62m completing an orbit in just over 122 days, and Kepler 62f, the outermost and coolest of the pair, sitting right at the edge of its star's habitable zone. None of these worlds, whether nightmarish or promising, are anywhere close enough for humanity to visit or verify directly anytime soon, with even the nearest superhabitable candidates sitting hundreds of light-years away, distances that dwarf anything current propulsion technology could realistically cross within a human lifetime. But that distance is also part of what makes the ongoing search so remarkable. In just over 3 decades since Wolszczan and Frail first discovered dead worlds spinning around a stellar corpse, astronomers have gone from confirming that any planets exist beyond our solar system at all to cataloging thousands of them, from planets raining glass at hypersonic speeds to gentle, temperate ocean worlds that might be more welcoming to life than our own home planet. Upcoming instruments, like the James Webb Space Telescope and the European Space Agency's Plato mission, expected to launch before the end of this decade, are anticipated to examine many of these candidates in far greater detail in the years ahead, hunting for the atmospheric signatures, water vapor, oxygen, or other telltale chemical fingerprints that could finally tell us whether any of these distant worlds actually harbor life, or whether Earth, for all its imperfections, remains the only truly living planet we know of anywhere in the galaxy.